Hello everyone, and today we will be seeing one of the problem from Gigs for Gigs. It says intersection in Y-shaped list. The problem is pretty simple that we are given two head of two non-empty strings, non-empty singly linked list, head 1 and head 2, that intersect at a certain point. Return that node where these two linked lists intersect. Cool. So they intersect and we wanted to return the node where they two intersect. Note it is guaranteed that intersected node always exists. So it is not a fake data which they have provided to us. It's genuine intersected list. In the custom input you have to give input for a common list which pointed to end of the both edge. Okay, if you wanted to run the custom test cases, you can go ahead with this. This is an example. So we have two linked list heads, which is 10, 15, 30, 10, 15, and then we say 30. Also we have a second, which is head over here, 6, 9, 15, 30. So 15 is the intersection point, as you can visually see from here, and they want us to return 15. Cool. Similarly, in the second problem, we have this linked list which is intersected at 1, and we wanted to return that one, so and so forth. These are the constraints, at least two nodes. Okay, cool. And what should be the expected time complexity? N plus n with auxiliary space 1. Oh my god, auxiliary space 1. This makes the problem much more interesting. In a way, how can you go ahead and solve this problem was, you can just understand the linked list, iterate 1. So I'll say list 1, store it into a map or set, whatever you wanted to call it. Then you go ahead and iterate list 2, and for each node check within list 1 set. So if you see that node exists in set, then it's the first intersection, and you can return right from there. So that can be an idea, but this requires a space complexity of O of n being the size of list. So they want us to do it in space complexity of 1. Cool. That's a good thing. That's a very good thing, by the way. How could we do this? That's the question. In an ideal scenario, or in the very best case, if we had something like 1, 2, 3, and I will say 3 is over here, 3, and second list also we have 10, 20, 10, 20, and 3, and 3 goes on 5, 4, 100, and whatever, 69, whatever, and null. In this scenario, we can just iterate upon this pointer and this pointer, because size of lists are same. So when the size of lists are same, I can have two pointers approach that, hey, this is I, this is J, and each time you go ahead advance this and this pointer, and when I and J both meet and those are equal, not in just data value but in the actual node pointer, if they are equal, you just go ahead and return that. This was the very best case, and we would not store any value in such case, but frankly this might not be the case every time. You can find few numbers like -1 over here, and that would spoil the entire things. So in this case, J would start not from 10 but -1. So that would be a question. Can we do something that we are sure that exactly I and J starts at same point from the intersection? This again brings out a question that you need to find an intersection, but hey, wait a second, You don't need to find an intersection for this. You just want it to start from the last value at the same instances. So if I'm having such kind of list, I just want j not to start from here, but to go ahead and start from here. So that's the only question. How can we do this? Spoiler alert, there are two methods to do this. Again, multiple ways you can do this. I know of two. If you know more than two, then do let me know, please. It would increase my knowledge as well. So how can we do this how can we make I and j to occur at same distance, I would say. So one cool thing is that, hey, you can count the number of nodes which are within the list, and once you get it, so and adjust your pointers accordingly. So for example, if you have first node as 100 and then you have next nodes count, list count, I'm saying L1 is 100, count of L2 is I don't know, let's take this example only. So 1 2 3 4 5 6, count of list 1 is 6, next count is 7 because we just added 1, so 7. So we know that L2 is has more numbers. So why not just start L2 first with epoch. I'm just making out the word epoch. Epoch does mean something else in machine learning and all, but epoch means an initial advantage, that you initially have these number of steps predefined. So L2 pointer here, j, should advance or pre-advance for L2 size minus L1 size, which is 1. So I would just advance j from this pointer to this pointer, and I am on the same side. Cool, this is one solution, but this requires us to count the entire array. Can we do better? Can we do better? So obviously the space complexity is still the same for 1 and 2, but what is harm in doing 1? One should ask that. If I'm going with approach 1, what is harm in that? Well, there is nothing harm. There's nothing harm. The factor is that you are iterating 2 lists and then you are processing for third one. So it involves overall 3 iterations, which is not very good. Provided you have 2 iterators and you can utilize 2 iterators. How can I do so? So you can have a pointer I and j. Let them start from actual heads. So the actual head is this. J would come here and I would come here. Let them start with the actual head and let them go on till the end. Go till the end. So once you go till the end, you'll see I would advance once and it will come over here. J would advance once, it will come over here, so on so forth. J would come here and the point I would come here. Notice every time J and I would have a gap of 1. Can we utilize that? Yes, obviously. I would advance J to point to 69. I would advance I to point at null, because beyond 69 is null. And now I want to advance again, but can J advance beyond null? That's a good question. No, J cannot advance beyond null because their null is pointing to nothing. So I would take J and put it over here to follow -1. Sorry, I would take I to follow -1, and this is how it would look like. Next time, if I says I want to advance, I would go to 10 and J would go to null. Now J is null. What I'll do, but wait a second, you see I is at the appropriate size where it should be. So what I'll do is I'll take j. Okay, next time when I'm advancing, I have advanced j to this and j to null. Correct. Sorry, my bad. Now I and j is, I can advance very well, but j cannot advance. J is on null. So what I'm doing here is take the j and put it in the list 1. Cool. Now I have advanced j, I will advance I as well. Both of them are in the same spot, where beyond them, like both are them in the exactly spot where we want it for a happy case. Happy case, number of nodes from the intersection points are equal. So 2 nodes to the intersection point, 2 nodes to the intersection points, and we are set. So yeah, and this is how the intersection point is, and you can just go ahead and iterate it one by one, and I'm sure that it will be equal on j and I. It would be equal on 3, and that's how we will return the 3. So start, go to the end, loop back with alternate list. That is the whole idea. Check equality, boom, and that's it. That is the whole point. So what are we going to apply? What are we going to implement? One is pretty much simple. Count the number of nodes in the linked list. It's very simple. You can also do that. I'll still attach a link over here how you can count the number of nodes in linked list, but it takes 3 iterations. We can do better, so we will implement the better solution. So for the better solution, I'll do just iterators. I'll have 2 iterators, itr1 comma itr2, where itr1 is equal to head1, itr2 can equal to head2, and I'll go till itr1 is not equal to null and itr2 is not equal to null. Or can I say like, okay, well, I'll clean it later upon. Now itr1 is equal to itr1 dot next, itr2 is equal to itr2 dot next. While the end of this loop, we are sure that we'll hit the end of either of one. So if itr1 is equal to null, else itr2 can be null. So if itr1 is null, L2 itr1 is equal to head2. So I can do better, I guess. I'm doing this while I see itr1.data, or guess what, not data, I'm just matching the pointers, right? Not equal to itr2. Until these 2 pointers are not equal, I'm not moving anywhere. I'm just doing my job. Cool, makes sense. So whenever we have seen null, we just go and set ourselves as this. So cool. Now what I'll do here is, if one is equal to null, I'll advance it last, or I'll advance it first, or doesn't matter, last or first. Yeah, it does matter. Wait a second. I'll rerun this program. I'll dry run this program first. What are we going to do here is, I is here, j is here, and if I see I here, j should be here, I is null, Can I go beyond null? Yes, I can. So I is null. The moment I is null, it would be like this, and the moment j is null, it would be set. Yeah. So this is the moment I and j can be null. So if I tr null head 2, if itr2 is null, itr2 is head 1, and the moment itr1 and itr2 is equal, we find the intersection node and we'll return the itr1 or 2, because anyways these both are equal. Let me compile this to understand. Hey, I have written correct. Yeah, let me submit this one for rest all test cases. Okay, sorry, zoom out. Yeah, it passed for rest all the test cases. So this was an explanation about how we can find an intersection in Y-shaped linked list. The topics are linked list and data structures. Okay, cool. Pretty much simple. I can do iterations as well, but iterator may not be. And as you can see, this is one of the very favorite problem from most of the companies, as it has been asked within these many companies. So yeah, this was all about it. For more such linked list and data structure related content, click the video on your right, and I'll see you in the next one. Happy New Year.